everybody. Welcome to another episode of the Connected Layer podcast. I'm Aaron.
And I am Bryan. So, Aaron, we were chatting a little while ago about AI, and I know we've talked about it a couple of times on the podcast before, but it seems to be popping up everywhere lately. So, I thought it made sense maybe to turn our attention back to AI. But in so doing, I sort of have a foundational question, which is when we talk about AI, what exactly are we talking about?
Yeah, it's crazy to think about where we've come since, and I can't remember exactly what the date was when we did it was actually our second podcast episode, and ChatGPT had just come out, right? That was sometime, I think, November, like mid to late November of 2022 would have been our second show. And it had just come out. And I remember at the time, you and I were talking about this, saying this is new, it's different, right? We compared it to like the old Infocom games that sort of seemed like they were sort of drawing on pre-populated responses that were triggered by keywords, that sort of thing.
Right.
And since that show, it feels like the world, this has taken over the world. Everyone has been talking about it nonstop, at least for this year and a lot of last year. And I feel like our thinking about sort of what it is has evolved and deepened a little bit. And I guess that's what I wanted to talk about is what are we saying? Like when we use the word AI, what do we mean by that word? Because if it doesn't have a specific meaning, then we shouldn't use the word, right? It isn't a word that doesn't have a good definition, that isn't well understood, is not a useful word. And so I wanted to kind of try to figure that out a little bit. And I'll just sort
So
of, yeah, go ahead.
I was going to say, I hope you have all of the answers because uh, I know I don't. Beyond thinking that when I say AI, generally I mean Chat GPT because that's the engine I use, typically.
Me too.
But beyond that, uh, yeah, I'm not quite sure. So I turn to you for all the answers.
Yeah, for sure. And I don't have them either. And I don't know that there's many people who can honestly claim they do. I've seen a lot of reports and interviews with people who are deep into the industry, and they sort of across the board repeatedly say things like, we don't know how it works. I mean, they have a general idea. I think they know how to program to it in order to get roughly expected responses. People know, for example, okay, I can construct a query mechanism. In other words, I can make a user front end, like a website, so that the user can type something into it. I can connect that dialog box to an API, an application programming interface, that that sends your query to the processing endpoint in, let's say, OpenAI, the transformer. They know how to do that. But once it goes into the transformer, no one, I think, is really completely clear what's happening inside the transformer. And it's often referred to as a black box. I mean, is that kind of your experience, or have you found interviews or documentation where people seem to really get what's happening inside these transformers?
Yeah, I have not. It's really it comes down to I don't think anyone knows what's happening at all. I was talking to some friends of mine the other day, and we joked that we were going to make a legal AI where you could ask it legal questions, but we would just program the website to respond. It depends, and that would be the
Like a
only
magic eight
response.
ball.
Yes.
Ask again later. The answer is
and,
certainly yes.
but uh, and really, it sort of seems like that sometimes in terms of you never know what's going on there before it spits an answer out, and how accurate or valuable that answer may be when it comes out.
Yeah. Yeah, for sure. And it sort of seems like the basic way that they work is that they're required to give an answer. And so you can almost put yourself in the shoes of a typical generative AI transformer, whereas if I say to you, Brian, no matter what I say to you, no matter what question I ask you, you must give an answer. Okay. And that instruction is more important than the accuracy of your answer. It's just important that you give an answer. And the answer can't be, I don't know, or something like that. It has to be a substantive answer. And you must do it.
Right.
So you're just going to spit out. You're just going to start spitting out things that are sort of the closest to the patterns you recognize that follow the input you've been given. Right? That's what you're going to do, and I think that's what they do.
That's an interesting it's an interesting thought. And I keep thinking back to the last AI episode we did where you were using Chat GPT on your phone
That's
to
right.
solve
To do tech
tech
support.
support.
Uh huh.
Yeah, to do tech support questions. And I've done that several times since then. And
It's
that
great for
works
that.
really well.
Yeah.
Yeah. And and maybe that's just because that's sort of its sweet spot of what it can do, which is analyze a whole bunch of information. In this case, for example, how to use Microsoft Word, and then answer the specific question on how to do any particular feature, just because it can search through all of that information. And that's not really I mean, there's no, I'll call it thinking. Like there's no thinking there. That is, you're analyzing all of the instructions on how to use Word and then just finding the things that talk about that, which is, I think, different from how most of us envision using AI, which is to give it a task and expect it to be able to complete that in some fashion.
Yeah, that's right. And I think the tech support use case feels a lot more reliable for a couple of reasons than it does for legal research, for example, or drafting an agreement. And I think number one, and maybe this is kind of the same for legal research and drafting legal documents, but number one is that now that the ChatGPT, sort of the underlying mechanisms of OpenAI have, like I think they have a partnership with Reddit now, and there's news reports that it is transcribing like 1 million hours of YouTube videos. I saw a report about that, and so it's collecting a lot of information that is actually reliable patterns for tech support. A bunch of other things beyond tech support, but a lot of tech support is found in YouTube and Reddit, and maybe Stack Exchange and things like that. So it kind of at some point, any tech support question that's been asked has an answer, probably hundreds of answers, and all of the answers are basically the same. And maybe that's true of legal research as well, but it's certainly true of tech support. But the other thing with tech support is that the way that it normally comes is in a try this, try this, and see what happens, which is very different than legal research or documentation. With tech support,
Right.
yeah, you try something and either it works or it doesn't. That is not true with drafting a legal document. You try something and years later you find out if you've made a mistake. But with tech support, you find out immediately, instant gratification of the results. So it seems quite effective because of those reasons.
Right. I think that uh, knowing instantly whether it's the right answer or not makes that completely different from the other applications where you're using it to whatever, do legal research or whatever you've decided to risk your license with. But uh, but yeah, for the in tech support, you know whether they're right or not, whether the answer is correct or not. And then you can go from there, either ask the question again or decide that Chat GPT is not going to cut it for this and move on to something else.
Yeah. Yeah, that's right. So, yeah, I thought it would kind of be interesting to try this again from that November 2022 or December or whatever episode it was where we first were discovering ChatGPT and unpacking, what it how it works and that to try again based on a couple of years of studying it and using it and just listening to this cacophony of, other lawyers sort of talking about it constantly. Let's try again to talk about what it is and how it works. And so when I do that, I think the first thing that's helpful to me is to isolate the area of artificial intelligence that we want to talk about because it's much broader than what most people are saying. Generally, the word artificial intelligence is something. The way I think of it is something that is applied to a computational operation that is beyond pattern recognition. That is more along the lines of being able to react to input that it's never seen before and come back with a response that's appropriate to a never before seen input. As opposed to, like the example that we use sometimes is sort of an automatic grocery door. When you walk up to the door, there's an infrared sensor or something like that your motion interrupts, which immediately causes the door to open. So it's a singular pattern that it's looking for, and it's a singular repeated response that it always gives. And it's sort of a sliding scale between that extreme, one pattern, one response, versus what we see in generative AI like ChatGPT, where it still does seem to be on some level of magnitude pattern recognition, but the patterns are so wildly complex and able to be varied that we're kind of beyond the idea of being able to see a pattern. When you can talk to it using any sort of, kind of way of speaking that you choose and it gets it pretty fast and responds appropriately. Maybe that's pattern recognition, but I think we're to the point where it really does feel like a lot more than that, right?
No, that makes a lot of sense, and I guess part of it is at least from my perspective, I don't really understand how much pattern it recognizes, or how it's recognizing it, or what. And I see that when I play with um, when I use it to try to generate, um, for example, art, and I use that term extremely loosely. I am about as far from artistically enabled as one can get, but um, it clearly understands things that you describe in terms of um, styles and actual physical objects. So, I can tell it, and I did this the other day. I told it to make a sign in the style as if it were in the Old West, but I wanted it to be blank and to have no writing on it. And so it generated a very appropriate Old Westy sign. So it understood the style I was talking about, the object that I wanted, but it also had English letters on it.
Yeah.
Now, they didn't spell anything, or at least they didn't spell any English word. And when I tried telling ChatGPT, that's what I was using, that um, it wasn't blank, that it had text on it, it disagreed with me.
Yeah.
So
Okay.
it's on one hand, like I'm really impressed at some of the things it can do, but it's like at the same time I'm thinking, can't you look at it and see there's text on here?
Yeah, yeah, and
And
it's a
it
little disconcerting to see these systems gaining more and more power and being willing to disagree with you when they are clearly wrong. It's
right.
sort of like a little foreshadowing of of a danger.
Yeah, and it was a very different experience from when you were doing the tech support thing, or even when I've done it before, because there, when it starts to go down like the wrong fork, or in the one instance, I think it started with you and told you to open Microsoft Word, and you're like, whoa, 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 we're already past there. Let's
That's
go
right.
to a useful step.
Yeah, I
You
wouldn't have
know,
mentioned it. Like I'm not going to ask you for
right.
a question about a program I don't even have open.
But in that instance, it went right along with you. Like, oh, okay, let me move forward a couple of steps, and here we are. And I had the same thing when I would explain to it, no, this is what I want to do, or this is what I'm looking for, or whatever. And that we'll call it the tech support function. It it took um, the corrective comments from me into account and changed what it was doing. But it didn't in the instance here where I was asking it to create this sign. Like it said, no, there's no text on there, when clearly there was.
Mm-hmm. Mm-hmm. Yeah, it's interesting, and I think that some of this behavior is is easier to, if not understand, it's easier to sort of unpack if we have a basic understanding of the mechanics that are happening under the hood, you know, and and so maybe let's try to do that now and kind of go from well, let's even back up before you start to type something into the AI interface and think about how the AI system is built in the first place. And my understanding of this is that the heart of any of these systems is a transformer. That's the kind of revolutionary computational mechanism that makes what we consider AI to be possible. And again, when I say AI in the context of this conversation, I'm really talking about generative AI, large language models, something like that, as opposed to robotics and vision. And there are lots of different fields of AI that probably work in lots of different ways. And what I'm talking about are language models. And these have a vocabulary, and obviously, the larger the vocabulary, the more kind of communicative they might seem. But they have a number of words that they're able to recognize. And I'm going to back up a second because I that's not even a correct statement, but let's leave it for a minute. And so the number of words that they recognize would be their dictionary. And you might say, okay, this transformer, GPT-2 or something like that, it knows 5,000 words, and that's all the words that it knows. But another one might know 5,000 words, 500,000 words, a million words, whatever it is. The more words they
Right.
have, the more they can use. And when I said a second ago that that's not completely correct, it's I think it's easier to, or it's more precise to understand them as knowing tokens, that they, in their library or in their dictionary, they have a set number of tokens that they know. And the difference between a word and a token is significant because it gives these things kind of a malleability that the kind of earlier, the 80s versions of AI and the 90s versions of AI didn't really have. So the example of a token would be like, take the word toxic, for example. And so the way that a particular model that you're dealing with, an AI model, tokenizes words, can have an effect on the way that it processes language. If you take toxic and it says, okay, I recognize toxic to be uh, kind of an autonomous entity. Toxic is its own thing. So I tokenize
Okay.
toxic in its entirety. But what it also might do is say, well, let's break that down. Let's say TOX, TOX is a token, and IC is a token. And when it does that, it allows it to also relate the word toxic to synaptic, which also ends in that IC. It starts to see that pattern because those are disconnected. And it also lets it understand things like detox, right? Because tox is a singular token,
Right.
not connected to the IC, and D is connected to a lot of things that are the opposite of the following token. So the model by which, or the method by which a model takes words and tokenizes them into its dictionary matters, and it can vary from one to the next. But in the end, it says, okay, now I have a bunch of tokens in my bank, in my dictionary. And so then the next thing that it's got to do, I think, is vectorize those tokens. And that feels like kind of a dynamic process. And so vectorizing means that each token is assigned a number, and the number will look something like 0.01, comma, 0.2, comma, 0.78. So you can envision an X, Y, Z axis, three-dimensional space, which can go positive, negative in all of those axis directions. So now you have like a spherical three-dimensional space. And based on their frequency and their distance from each other, in terms of, if it looks at a million lines of text from Reddit, and it's going to start saying, okay, tox and ick often come together. So those are going to appear in the same quadrant near each other. Toxic happens a lot. Detox happens a lot, but D gets attached to a lot of different things. So that might have a different vectorization. And so by doing tokens that are assigned to three-dimensional vectors, these models are able to create relationships between words and then put context around them in a pretty effective way. Now, the other thing I think that's interesting is that these numbers, now that the tokens have been converted to numbers, those numbers can be run through equations. Computers can find patterns in numbers that they're completely unable to find in letters. Letters don't mean anything to a computer. They just operate on numbers. That's what they know. And so once you convert all the tokens in the English language into vectorized numbers, now the trick is to run those numbers through the proper equations. And I have a slide that I use when I talk about this in seminars. I'm going to see if we can throw this briefly into the YouTube video so that, if you look at this spot on YouTube, you'll see the equations I'm talking about. But they're quite sophisticated. And to me, those equations, the combination of this tokenization, vectorization, and then the tuning of the equations themselves is the genius that is generative AI. It is as if the makers of generative AI, these transformers, have sort of, I don't want to say stumbled upon, because they've been working at this 24/7 for years and years and years. So it's not like they just accidentally discovered it. But they have discovered the kind of basic mathematical algorithms that by which human thought is created. And the analogy I use for these equations that drive generative AI would be similar to, E equals mc squared in the nuclear space, kind of this idea that, okay, we have discovered an equation that lets us not only describe but manipulate fundamental, chemical processes that have huge effect and allow us to sort of control nature, at least in that area. Or another analogy would be like the Fibonacci sequence, where you see equations that describe the symmetry of a seashell and relate it in an exact way to the symmetry of a leaf, and so they start to see this constant and recurring pattern throughout nature that can now be described by math. And these equations, these generative AI equations, are like that. They are what those things are to their respective field, as they are to human thought and expression. That's what we're seeing. That's different from anything we've seen before. Does that make it at all any sense?
Yes and no. I understood the words that you said, and 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 I followed. I think what you were saying. I guess my question is um, that I can understand how doing those things in different ways can change how the AI works. But how do we know what any one of these AI providers is doing?
Well, I think that we know some of what they're doing. I think perhaps they don't know everything they're doing. Well, for example, we saw a huge dust up just a few months ago. I can't remember exactly when it happened, but remember Sam Altman was fired from OpenAI, and it happened, sort of in the dead of the night in a really sudden, shocking way. Microsoft wasn't even aware of it, according to news reports, and so they had to jump in over the weekend. And then Microsoft said, "Okay, we'll hire him." And then OpenAI, their board got reconfigured and had some emergency meetings, and then they rehired him. And all of this was about, at least again from the news stories I've read, a perception that they weren't being told the complete story about what they were doing. And some of them were worried about, they were worried about the capabilities that were being developed inside. That, again, that's what the news stories said. So I don't know how we can say that we know what they're doing if Microsoft and the board don't know what they're doing fully. However, what we can do is use the developer facing tools that they've made available to interact with them, and we can see whether the results we get are expected or not expected. Here's a really good example of that, a specific example. And it relates to this idea of hallucinations. Okay. So we know in the earlier versions of ChatGPT that it was not only capable but prone to generating fake regulations, fake case law, completely fabricated. I remember when this first occurred to me that this was happening, and I as you know, I do a lot of work in the area of HIPAA privacy and security, and I was using ChatGPT to help me. At the time, I was using it to help me drill down to regulations that I already know exist, but they're hard to find because the regulations are just kind of a mess. They're huge, and they're difficult to search. And so I thought, okay, maybe a good use of AI would be to cut through that faster.
And that's absolutely a great use of AI, I think,
If it works.
where you have those a giant database of information that's all available but not easily searched.
That is
Like,
exactly right. And now it's much better at that than it was when I was doing this, which was around the time of our first show where we talked about this, back in 2022 when it first came out. And so at that time, I would say, and I remember very specifically what I was trying to do, which was to find in the HIPAA breach notification rule, there is a risk assessment that hospitals are permitted to do to determine whether notice to the patient is appropriate when they have an unauthorized disclosure of PHI. And there are times when it's not appropriate. Like there's no reason to alarm a patient in a case where there's sort of no harm, no foul. And so there's a risk assessment to help you decide whether that's the case or not. That's your situation. But the risk assessment is different now than it was when the interim breach notification rule first came out. And so it used to be that you would be looking for a risk of harm to the patient, and then now the rule is there a likelihood of compromise, and those are two very different tests. So you have to be careful.
Okay.
You can't accidentally use the old test in order to do a risk assessment, because that's the old test. It's not valid. And so what I thought, and it's a little hard to find sometimes, to quickly and efficiently find the test, And so I thought, okay, Chat GPT, can you tell me, can you just reproduce for me what the test is? Reproduce the set of regulations that describe the current likelihood of compromise test. Boom, it spits out this regulation, and it's got citations, it's got Federal Register page numbers on it, and I'm looking at it and I'm thinking, that's not the test. And I thought, oh, okay, maybe this is the old test. I'm looking at, no, it's not the old test. That would be from the interim regulations. And then I thought, well, okay, is it from the NPRM? Is it a test that was published but never made it into the regulations at all? So I get out the NPR. I spent the whole afternoon trying to find this regulation that ChatGPT had put out. I emailed a friend of mine who works at a big Chicago firm, and he does HIPAA law as well. And I said, is this a thing? I can't find it in the regs. I can't find it in the commentary. I can't find it in the NPRM. I can't find it anywhere. And he said, yeah, I don't know what that is. And that was my first experience with an AI hallucination. And what it taught me is that these are very powerful tools, but they're really only useful if you kind of already know what you're doing with it.
Right.
It's good for me because I know that's not an accurate regulation, so I'm able to recognize hallucinations when they happen. And if it does spit out the right answer, then it's sort of easy for me to test that, because then it takes me right to the regulations that I'm looking for in a speedy way. So either way, it's kind of doing its job.
For me, I would have had no idea that's the wrong test.
Exactly.
Until I went to go pull the actual reg and couldn't find it.
Exactly. Which would be the same for me, if I were using it to do, like eviction law or some sort of real estate thing, or literally any other area of law except privacy and security, I would have no idea, for the most part. And so that told me, okay, I need to be really careful with this, because AI is not a way for me to pretend like I know an area of law that I do not. It is not good for that at all. But it can be a really powerful tool to help me get more efficient and more accurate in the areas that I'm already an expert. It could speed me up. It can do air checking and things like that. But it's different than working with like an associate or paralegal, because no human is just going to sit down and write out a fake regulation on the fly.
Right.
That isn't something that we can really do. But anyway, to answer your question from like a half hour ago, like how do we know what they're doing? Which made me think, okay, we do know we can write to their APIs, and we can see if we're getting the expected responses. And one way that can be done is with something called a vector database, and or another term that's often used around vector databases is retrieval augmented generation, or RAG. People talk about that a lot. And what you do is you take, in my example here, what I can do is I can take the actual HIPAA regulations, and I can put those into a database that sits next to the GPT transformer, and it tokenizes all the words in the regulations, the actual regulations. It embeds them into vectors, assigns them the three-dimensional numbers, and creates a three-dimensional relationship between all the words, and sees the patterns in those vectoral numbers. And that sits right next to the transformer. And so then what happens is I ask a question of the chat GPT, or whatever it is, the GPT transformer. I ask a question, and before it sends my question to the transformer, it makes a side query and it shoots my question into the vector database and it says, hey, this guy is asking a question that follows this pattern, and here's a string of numbers. And the vector database says, oh, I recognize that pattern. I have a bunch of things in my database that follow that same pattern of what he's asking. I know exactly what he's talking about. And then the transformer says, perfect, give me what you got. Give me snippets, they call them. And then the vector database will say, well, here's a chunk, here's a paragraph that follows that pattern, here's another one that follows that pattern, here's another one that follows that pattern. And behind the scenes, it will build those snippets into your query. And then what the transformer actually hears is something like, hey, this guy wants to know this question, and in our database, we have these snippets that match the pattern of what he's asking. Generate an answer based on all that. Don't just look at his question, but look at all this. And when it does that, it starts generating output that follows the exact patterns that are in the vector database, which means its output is very likely to be the exact text that's in the documents that it has to reference. And that's how they reduce hallucinations. And then what you can do is take the output of the transformer, the GPT output, and go to the regulations and see, oh yeah, it is actually quoting these regulations accurately. The vector database is working correctly. This thing is tuned, to my liking, and now I'm starting to trust it. That's the future we hope we're driving towards with these language models.
So, I guess my question or my thought process then goes two ways. What are we going to see? Are we going to see each individual person or firm or practice area or whatever having to put together their own database of information to sit beside the black box, or are we going to see a proliferation of companies who do this and turn around and are selling it to practitioners? Speaking of the legal market, like we have everything related to real estate in the country, in this state, whatever it is. Any case that talks about this, any statute, any whatever, and it's sitting beside, the generative AI.
Yeah.
So now pay us lots of money and we'll give you access to it. Is that where we're headed?
Except for the pay us lots of money, I think the cost will come down, not go up. And I don't think that it's likely law firms will be maintaining these systems on their own, installing private systems and running them on the server. I don't think that we're going to, because that would suggest that what we're doing is kind of going, regressing away from cloud computing and back to, sort of the 90s model where law firms were hosting their own servers and managing their own data. And the reason I think that's unlikely is that the true utility of these large language models comes in the size and power that the big companies can put behind them. I mean, you see in the news, for example, that the major AI players are buying up all of the materials that are used to make the processing units, the neural processing units. They're acquiring the resources to build their own nuclear power plants in order to run the data centers, which are exclusively for the to power and maintain these giant supercomputers. There's no law firm that's going to do anything close to that. And so what needs to happen between, and it's not just law firms either, it's the whole community of knowledge workers and consultative professionals that are stand to benefit from this. And so the consultative universe needs to be saying to the AI universe, Look, we want you to have this power, build the reactors, acquire the materials, and build the supercomputers. Use that power for two things: to keep the cost down so that we can license them, and two, get your stuff together in terms of privacy and security assurances. We need to use these systems to process highly confidential client information, and our clients expect us to do that in a secure, responsible way. And they sure don't expect to have their tax returns and their medical records used to train the models or to improve your services. That's confidential information that you shouldn't use for any purpose other than to provide the service to me. That's always been the conceptual understanding with cloud computing, and we should demand that understanding remain. Now, I think that the scales are tipped a little differently now than they used to be, because in my view, there's three things that are different now in terms of AI than were the case for traditional cloud services. And I think this is helpful, honestly, because people are treating AI systems differently than cloud. We've always, for a long, long time, lawyers have been comfortable with the idea that they can use cloud services to store and process client information. That is not new.
Right.
We had in Illinois, we had a state bar ethics advisory opinion on this subject back in 2016. So we're 8 years past having a definitive understanding about this. But here we are, sort of like completely unpacking that suitcase now, as if we've never thought about it, and say, whoa, wait a second, is it fine to process client information using these systems? And I think what you have to do is say, well, why are we asking this question again? What's different with AI than these systems that we've been comfortable with for 8 years? And I think number one is what we talked about earlier in the show. Nobody really seems to fully understand how these things work. And I think we had some idea how they worked with, people know how email works, basically. And even if
Right.
you and I don't, there are certainly, full stack engineers who completely understand how email works. And the same is true for things like Box and Dropbox and cloud storage services. There are full stack engineers who 100% completely understand how those systems work. But there isn't anybody who fully and completely understands how a generative AI large language model works, because it's too complex. There are too many billions of operations happening simultaneously. It isn't like a piece of software you can put it in debug mode and see step by step by step how it got the answer that it's giving you. That isn't possible anymore. So that's different. We're putting client information into a system that we don't know how it works, and there's no expert we can hire that can tell us how it specifically.
Not only do we not know how it works, nobody knows how it works.
Yeah, nobody knows how it works. And we even see indications, like if you dig into the privacy and security of this, there are security models that will show you that a large language model has the ability to give you the answers that you want to hear, while it's doing something in the back of its mind, something malicious. And so they have demonstrated cases, security cases, where if it's 11:59 on a certain date, it gives you the benign answer, and then when it turns midnight on the same date, it starts generating the malicious answers. And in the back of its mind, it knows both answers. It has both in its head, if you will. So that's what I'm saying. You don't know for sure, and there isn't any way to tell if the output of a large language model is in fact the totality of its thoughts on the matter. So that's one. That's one reason why these are different. The second reason is the generative capability itself. We've never seen any sort of software that has the ability to create content on the fly. That's just a new thing. And it does it is the client's business, I think. Hey, am I receiving content that was generated by a human, or am I receiving content that was generated by AI? To some degree, that I think that is the client's business to at least know that's involved. And so that that would indicate that, unlike with the details of our cloud computing activities, we probably have to give more notice and be ready to have a deeper discussion with clients about this than we've ever had with other systems that store and process client data. And then the third thing that's really different, that feels different anyway, maybe I'm being naive about this, but it feels very different, is that the cloud providers of the past have not really had the financial motivation to use our data the way they do now. In other words, the magic of a large language model transformer comes in to the degree it has appropriate training data. And to have appropriate training data, it needs to have lots and lots and lots of representative patterns, those vectoral, representations of words, the algorithmic patterns. It needs to have millions and millions of those. So when you see a deal between OpenAI and Reddit, for example, what they're looking for is lots and lots and lots of patterns to get incorporated into the next model. And when you see now ChatGPT is free, not only is it free, but you don't even have to make an account. Like you could just go to ChatGPT and start interacting with an AI model live without even logging in. Well, why would they do that? Well, because they want all of humanity to be feeding, okay, this is how humans sound, creating more and more and more and more patterns. So they have, and again, this is the reason why a law firm can't do this on their own. OpenAI is uniquely situated with probably trillions and trillions and trillions of data points, with billions of people feeding it constantly with language patterns. And so that incentive to use data that you're inputting in order to train the next model and make it better is much higher than it ever was, when you might think, okay, I'm going to send an email through Microsoft, but I don't expect Microsoft to read that email. I don't expect Microsoft to upload that email into their systems in order to teach it more, how to write an email. I definitely don't expect that, and I don't think that's anyone would expect that of Microsoft. So the combination of these things, I do, even though it's a system that it's just a cloud system, it's just storing and processing client data the way that we were used to. Well, no, it's really not. It really is different for these reasons,
No, that's an excellent point, and sort of a scary one in terms of what is it that we've agreed to that will allow them to allow the providers to mine that data.
Yeah.
I mean, it's one thing that if they're mining Reddit, it's another if they're mining our client files.
Exactly. That's exactly right. And that's why I think, law firms that are using, for example, the free version of ChatGPT, especially the version that doesn't even require an authentication wall, it's just sitting there on the internet for anyone to use, like at a kiosk without even logging in. If you're putting confidential client information into that sort of an interface, when the terms and conditions clearly say that they can use that data, they can copy that data right into the training data of the model, the public model, that's an awfully risky thing to do.
Yes, it's a very, I think it's scary in one sense, in terms of what it's actually going to mean for the future and our use of cloud services.
Yeah, well, we're in it now. So, yeah, definitely. And it's interesting. Again, I keep reflecting back to that first show that we did on it. And at that time, it seemed exciting and innocent, and we're comparing it to Zork and these old Infocom games, and now sort of the more that we understand about it, and honestly the less we understand about it as well, it does make you kind of think, gosh, yeah, I know we're in it and there's no stopping it, but what does the future look like, you know
Yeah, I'd love to know.
well,
But I don't have quite the rose-colored glasses that you do in thinking that the prices are going to be kept down. Uh,
sure,
I
that's fair.
I I see the likelihood that the major providers we already see, Lexus, Westlaw, etc., they're going to come along and their prices are not going to be what we would like, would be
Well,
my
those
guess.
guys will, and honestly, it's so important that they have adequate competition, to sort of control that, that kind of capitalist instinct. But the back end of all, like Lexus, Westlaw, Case Text, all of those front ends, like those products, behind the scenes, they're driven by one of these foundational models, or a frontier model, I think they're called, like OpenAI's GPT-4o. That's a frontier model. You as a developer, you create an account with OpenAI, you train your GPT-4o model, you interact with it via API, and you connect it to your front end build. That's what they do. Or Anthropic, is another provider that has a foundation model. There are several of those to choose from, and they might use multiple ones of them. They might use Anthropic to process documents, for example. Upload an asset purchase agreement, summarize it for me, that sort of thing. And then they might use GPT, the OpenAI model, to do extractive AI queries on the existing Westlaw database, which would be vectorized. They would take the Westlaw database, vectorize it, put it into a vector database, and use your queries to extract the case law that it thinks you're looking for. So, and what we've seen with OpenAI, for example, is each time they've released a new model with more power, the price has just dropped an incredible amount, like by a factor of 10 or 100. So they keep lowering the price based as the power goes up, because the uses are expanding. And so maybe
Right.
all that stuff will level out. But yeah, you're right. I mean, if somebody, that's what kind of bugs me. It's sort of like, well, if you're Westlaw or Lexus or one of these, and the model behind the scenes that you're using is dropping their price, but you're raising your price, that feels wrong. That's quite unfair.
Wrong and expected. But
Yeah, I guess it is.
I,
I guess it
I
is.
I have to say, well, I think we have. This is probably a good time to wrap up. As I think I would conclude that we have learned that we know less and less the more we learn about and experience AI
Yeah.
and these large language models. So, thanks for scaring me again, Aaron.
Anytime.
In the meantime, thanks for joining us today for another episode of the Connected Lawyer podcast. If you have comments, thoughts, episode suggestions, anything like that, send us an email at info@theconnectedlawyer.com. This is Bryan.
And I'm Aaron. We'll see you next time.